Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Kyle from Business Review, and I'll be your host today. It's our pleasure to have OSI11 with us, who's presenting this webinar entitled The Real Value of Digital Transformation for Mining and Metals Companies. Today's guest speaker is Martin Provencher, Industry Principal for Mining, Metals and Materials at OSI11. I'd like to welcome you all to our webinar platform on 24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please click on the link you received via email to rejoin the session. If you want to ask any questions, you can send them in via the questions widget. Just type them into the box at the top left-hand side of your screen, click Submit, and we'll have some time at the very end to address any questions or thoughts that you may have. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But for now, please allow me to welcome Martin Provencher. Over to you, Martin.
Thank you very much, Kyle. So good morning, good afternoon, everyone. Again, my name is Martin, Industry Principal for Mining, Metals and Materials at OSI11. Today we'll actually have a discussion on the value of a digital transformation approach for mining and metals companies. So we'll start by introducing some key aspects to perform a successful digital transformation. And we'll look at an important topic, which is how to empower people to help organizations succeed in such a journey. We'll also look at the improvement results that can be obtained and how we can capture invisible losses, which are mainly production losses or financial losses. And one of the most important loss, actually, or aspect that generates loss is asset reliability or asset availability. So this is a topic that we will be covering in a little more details. And then finally, how a successful digital transformation strategy can lead to autonomous operations to help us increase quality, stability, and help optimize process efficiency. So a lot of people are talking about digital transformation. What's important to understand is digital transformation is a business transformation. It's not necessarily an IT-related transformation. It is really a business transformation. It improves the way you operate your business, and of course, it will help you improve your results. But how can we succeed into that kind of journey? What is required to perform such a journey, and what value does it really represent for the mining and metals industry? That's what we will be covering in today's webinar. So it's a fact. Digital transformation is changing the industry. The change is more about the fact that we are now using the data. We're using the operational data to operate more efficiently, to open new revenue streams. But what is operational data exactly? Well, it's basically data coming from operations, material handling, mobile assets, processing, data coming from sensors, from GPS system, dispatch system, PLC, SCADA, etc. So it is real-time data, but it is also historical data and future data that we'll take into consideration. That data can be collected manually, but ideally, of course, it will be automated. Now, how that operational data can really transform the industry? Well, here we have two good examples. The first one is Goldcorp in the mining industry. They've implemented a dynamic simulator to provide operators with real-time targets based on the feed grades that were coming in the process. And this resulted in a 4 to 5 days additional production in the first 6 months. So this is significant. This is additional production because they are using data, operational data. Second example here on the right is the Algoma Steel Mill, which is both a primary and fabricated metals company. They took advantage of real-time operational data to optimize their processes, which contributed to many advantages. For example, they've extended the life of their blast furnace. So the relining went from a normal 7 years lifespan to more than 12 years. They've also achieved a reduction in their unplanned delays and the direct strip production complex, which resulted in 140,000 tons production increase. So this is a significant improvement that they have achieved using operational data. Now, digital transformation is happening, but not at the same rate everywhere. Based on a McKinsey study that was performed late 2018, only 16% of those that do get into such a journey do succeed. So 16% is not a lot. So companies invest millions of dollars in digital initiatives, Industry 4.0, IIoT, Industrial Internet of Things, advanced analytics, etc. But they're not getting the value out of it. Why? Why is this? Well, data is valuable, but it is not magical. This is what we have to take into consideration. There is work required to turn data into intelligence. So real-time operational data is what happens now. And there's a difference in having access to the data in hours compared to in seconds. And that difference can result in millions of dollars of lost production or repairs or even catastrophic incidents if we don't get the data on time to act when there's an emergency. So in summary, data does not mean information. It has to be contextualized first. So first, you need to capture the data automatically. There's a lot of it. A single pump can generate over 100 data streams at frequencies from milliseconds to hours. Then you need to contextualize that data, so it means something. So which asset are we talking about? Where is it located? What is it that we're measuring? What are the units? This is the context that comes with the data. We need to align the data so that it needs to be structured sequentially in a timely manner so that it is useful. When did that temperature started increasing? That's important. That's an important aspect that we have to take into consideration, that we have to know. And then we need to provide access to that data for real-time decisions to be taken. You know, data is a lot like bread. The fresher it is, the better it is. Now, the idea is to provide access to operational intelligence so that the same information is accessible to everyone. One source of the truth. Everybody has the same information so that they can act on it. Now, who wants that operational data? Well, for example, a production manager may use it to forecast and track productivity. A process engineer may use it to optimize the process to improve yield and productivity. Again, same information shared by different people. A maintenance engineer may use it to shift from a scheduled or condition-based maintenance approach and ensure optimal asset health and OEE. So this is when you start to empower your people. But what are the challenges that happen when you start empowering your people with the data? Well, there's a good quote that was stated in that McKinsey study that the technical challenge is to build visualizations and user interfaces that synthesize large amounts of data into formats that can be easily understood by human decision makers. And this will empower our people. Now, back to you, Kyle, for our first polling question.
Thank you. To take part in a poll, everyone, just click one option, click submit, and wait for the next slide. All right, but our question today is, who in your organization has access to real-time operational data? Everyone has access in real-time to operational data and can perform analysis. Only some engineers and analysts have access to real-time operational data. Only our operators have visibility on real-time operational data through DCS/control system. Or we do not have access to real-time operational data. All right, so let's give everyone a moment just to think about that. But Martin, do you have anything you want to say about this question in that time?
Yeah, sure. Actually, it's interesting. It will be interesting to see the results of that poll, because I would assume that most operators do have access because they are managing their DCS, their control systems, so they are operating in real time. The thing is, and the challenge is there anybody else that have access to that data? Some organizations will typically get or do manual polling or manual intervention to get that data and bring it into spreadsheets for future analysis. But of course, once you do that manually, typically it is not automated and then it's not in real time. So that's the real time aspect here is very important, and I'll be happy to see the results that are coming out of that poll.
Okay, well, let's see how that went then. There you go, looks a bit of a spread of results there. Does that look about right to you?
Yeah, that looks pretty what I was assuming. So it's interesting to see that 18% of the people are saying that they have access to real-time operational data and can perform analysis. That's very interesting. Now let's get a little bit deeper to see what we can do with that real-time operational data. Thank you very much, Kyle. So so next we'll look at the ways to empower our people. So once people have access to that operational data, we need to empower them. We need to make sure that they're doing something with that data, and that's a challenge. The idea is to provide our people that access. So for example, the operator on the crusher, of course, in the mining industry, uses his PLC to see what's happening on the machine, but he does not necessarily have the real-time view of the whole process of what's happening upstream and downstream. But for example, what happens if the conveyor is stuck 1 kilometer downstream? He wants to know in real time what's happening, because he might have to do something about it. He might have to reduce its speed or even stop its crusher. So that's an important fact. So he needs to have the global view. Another example is the maintenance engineer. He might want to perform an ad hoc investigation on a specific asset. So he might want to do analysis to identify historical conditions that led to an eventual failure or that led to that failure. And then he will be able to implement condition-based maintenance in real time on its operational data infrastructure to generate, for example, a maintenance work order automatically before the failure occurs. So empowering our people is providing them tools so that they can take better decisions, which will have an impact on our financial results and, of course, on productivity. So again, according to that study from McKinsey, there are key factors that have to be in place to succeed. And here I've taken the three of them that I think that are probably the most important ones. First one is you need a clear alignment from management. As I said, a digital transformation is a business transformation. So management needs to be involved into that kind of transformation. Second thing is people need to have proper tools so that they can have access to that information. Again, data, once it is contextualized, it becomes meaningful and it becomes information. But data without context is not information. And lastly, I mean, empowering our people so that once people have access to all that meaningful data and that same meaningful data so that we have one single source of the truth, then we can say that we have the three important success factors to succeed in such a transformation. And those that do have those factors actually are succeeding 3 times more than the other ones. So that's quite interesting. Now here we see some examples of digital tools that are empowering people. Those tools will provide intuitive access to operational data in real time. And they can find information they need easily. So in the first example on the left, we see a real-time dashboard in a remote operations center that actually helps to improve situational awareness for mission-critical operations, no matter where it is located. So that's quite interesting. On the second example, we see a subject matter expert that is empowered to explore the data and better understand what's happening with the asset that he's looking at or at the process that he's looking at to find new cost-saving opportunities. And a third example is, for example, using a third-party application that can streamline and automate tasks such as regulatory reporting, for example. So all of these tools are available once you have access to that real-time operational data and once you have access to that same real-time operational data. Now here we see a good example of an organization that performed a successful digital transformation, and they empowered their people to help improve their productivity. So Alcoa has a number of aluminum plants all around the world. Those plants are very large and they consist of large number of pots, between 300 and 700 pots typically per plant. Those pots use metallurgy and energy to produce molten aluminum. So before this project, they had a variety of systems that were not integrated. They did not have standard ways of calculating KPIs, so it was difficult to do analysis or troubleshooting using operational data. So they started the project called Smart Manufacturing to rationalize and standardize their operational data infrastructure. So by regrouping and organizing all their production data at each plant into a single repository and data model, Alcoa has successfully supplied its employees an efficient, powerful, and easy-to-use source to gain global insights into operations. So employees now have access to all operational data and share the same information, which of course led to increased operational efficiency and proactive decision-making in their dynamic environment. So this is a very good example of a successful digital transformation. So based on a 2019 Aspermont research study that was performed for OSIsoft over more than 100 mining executives around the world, it's interesting to see that 51% of organizations have started a digital transformation journey. And 14% of them, or actually 14% of the total number of the people that were surveyed, are saying that they are pioneers in their use of their digital technology. So it's interesting because it matches the 16% that were successful in the McKinsey study late 2018. So there's a match here. It's quite interesting. Now, what is more disturbing, if I can say it like that, is that 33% have not started collecting real-time operational data. So that means that these companies or these organizations are currently facing invisible losses. So they are basically losing money because they're not using the data. And this is what we will be looking at for the next part of that webinar. Actually, how can we capture those invisible losses? Now, how do company benefit from digital transformation? Well, we've already seen that Goldcorp has recovered zinc production that they would not have been able to without using operational data. We've also seen Algoma Steel that increased their production by 140,000 tons, again, with operational data that they would not have been able to achieve without the operational data. So, and this is exactly what we will call invisible losses. So those would have been lost if we would not have taken advantage of real-time operational data. Now, digital transformation can bring significant value to mining and metals industry. For example, here are some of the main areas where we see value coming out of. In terms of process productivity, of course, having access to real-time operational data by the operators, engineers, managers can help them make or take actions quickly, which can represent significant productivity improvements in many cases, as we've seen with the Alcoa story. The issue that companies are facing is that they have many data silos with lots of different information systems that were bought over the years that are generally not integrated, so that means that we're not able to get the big picture. For example, for some metal companies, their operating processes can involve significant numbers of parameters and adjustments. So increasing production means that we're pushing the limits of the different processes and are very often hard to manage for human beings. So having access to real-time operational data and implementing process condition monitoring, for example, in real time, can help them significantly increase their production throughput. In terms of energy and water management, so those companies are having to actually have to start monitoring and managing their spend on energy and water because those costs are increasing significantly in these days. So again, lots of different information systems that are generally not integrated. So knowing in real time what consumes most energy or water can help identify leaks or even equipment that should not be running. So again, real-time condition-based energy or water monitoring can help generate significant savings. In terms of asset performance or asset reliability, well, of course, I mean, this is an industry where it's an asset-intensive industry, so anything that can be done to increase the uptime of the machines is worth a lot. So having access to real-time operational data opens possibility for maintenance to go from a reactive mode or a planned maintenance mode to a condition-based maintenance. And actually, even go further using advanced analytics technology, which can lead to predictive maintenance, for example, predictive maintenance 4.0, which is using real-time operational data. And we may even start thinking about prescriptive maintenance when we're starting to use artificial intelligence. In terms of environment, health, and safety, well, with all the new regulations that are coming in, companies are actually need to manage that properly. So not meeting some compliancy rules can result in major fines or even suspension of operating licenses. So these are becoming very, very important. So lack of automation and communication makes it very difficult to manage. And again, having access to real-time operational data will allow them to take actions rapidly and avoid non-compliancy events. And also, if we can think, again, implementing condition-based environment monitoring, for example, on specific compliancy regulations or rules, can help improve situational awareness. In terms of quality, products must meet a variety of specifications, customer specifications, standards, regulatory, etc. So lack of real-time notifications for product quality deviation makes it difficult to know at every step of the process what's happening. So it's usually done afterwards. Once we realize that the product quality is bad, then we take action. So the idea is to take action the sooner, the better. And then, of course, I mean, in terms of KPI reporting, having one version of the truth, like I said, many companies are facing data silos and lack of integration throughout the value chain. So they're not able to get the big picture. So having access to real-time data across all assets, all plants in a standard way makes it much easier to report. And this is exactly what happened at ArcelorMittal Mines Canada, which is the largest Canadian supplier in iron ore to the steel market. They operate 2 mines in Quebec, Canada, a pellet plant, a private port, and a 420-kilometer railway link between those sites. In 2011 and 2012, they had an expansion project to increase production from 16 million tons to 23 million tons. They were then facing operational and logistical issues through their supply chain because of the complexity of having the ore extracted and having it shipped at the right time. So using the price system, using their real-time operational data infrastructure, they were able to collect all that operational data throughout the whole supply chain and transform that data transfer the data actually coming from the different systems to enable strategic and rapid decision making. This allowed the optimization of their operations and logistics, including heavy equipment in mining, railway, port infrastructure, transportation, etc. So the results were astonishing. They got 13% increase from 23 to 26 million ton, and it represented $120 million in additional revenue in 2015 without any capex investment. So that's a significant digital transformation success story. In terms of energy efficiency, again, what is more invisible than energy when we're talking about invisible losses? Well, even though it is invisible, there are costs associated to it. So Southern Copper is one of the largest copper companies in the world, and they use their real-time operational data infrastructure to collect data, again, from different systems. They performed analysis to identify the correlations for energy and water usage, and the results were basically they increased the production by 4.6%, they decreased power consumption by 3.9%, they decreased the fresh water consumption by 6.8%, and all of this resulted in $800,000 of savings per month. So again, a great success story of a successful digital transformation. Now, once organizations have started their digital transformation, there are some priorities that were identified. Based on that study, that 2019 Aspermont research study that was performed for OSI Soft, it's interesting to see that 47% of executives identified health and safety to be the most important priority to focus on. Of course, there is a lot of behavioral aspects to take into consideration when we're talking about health and safety, but real-time operational data can help significantly here. And this will be covered in a future webinar, as this is a big component that we would like to cover. But another interesting result is that 39% of the respondents strongly agree that artificial intelligence will help improve decision making, and this will be covered today in the webinar. Another OSI Soft survey identified also that 47% of the people think that maintenance is the #1 invisible loss to capture. So we will cover this in the next slides, actually. So improving asset reliability is the fact that we need to make sure assets are functioning properly And at the same time, we also need to ensure they are properly maintained. So there's a balance that is required here. So a study from the EARC advisory group about preventative maintenance based on a calendar-based approach revealed that only 18% of assets have an age-related failure pattern. So that's a little bit disturbing, because it means that there is excessive maintenance that is performed on some assets, which represents costs and time spent on the wrong assets. Also can represent parts that are prematurely replaced, which also represents unnecessary costs, but also generates downtime for maintenance shutdown to replace those parts. And what about the assets that were not, or that are failing during that period? What about the assets that have been used extensively during a certain period? They might require maintenance earlier than the calendar-based approach. So this could also represent costs, but also risks in terms of production and health and safety or environment. And this is why companies are aiming at becoming more and more predictive in their maintenance strategy, and even becoming prescriptive. So a study from Deloitte on the impacts of implementing a predictive maintenance 4.0 approach or strategy. Again, 4.0 means that you're using real-time operational data, shows that it can increase asset availability by at least 10 to 20% and reduce costs by at least 5 to 10%. Those are significant losses, invisible losses. And this is a step-by-step approach. And real-time operational data can be exploited much earlier. Once you have access to that real-time operational data, you can start implementing condition-based maintenance into your real-time operational data infrastructure. And then after that, once you can start using analytics, and then here you see that there's an overlap between condition-based maintenance and predictive maintenance, because once you start using analytics with conditions or multiple conditions, then you become proactive. So this becomes proactive maintenance, which is becoming predictive. I mean, you're starting to be able to predict that there will be a failure. This has a significant impact in terms of downtime or preventing downtime, and also reducing costs of downtime. And this is exactly what Syncrude Canada, a crude oil producer in Alberta, has started doing with their haul trucks, with their maintenance strategy. Syncrude operates 2 large-scale surface mines with 136 heavy haul truck units, shovels, graders, etc. And as you can see with the picture, they operate in a harsh environment, so it has an impact on their asset maintenance and reliability. So they started monitoring their mobile equipment attributes like engine turbo, injector failure, braking condition, temperature, the brake pump cycle, etc. And they did a pilot project which was very successful. Once they started implementing those condition-based maintenance approach for their haul trucks, well, they saw significant improvement in their maintenance and reliability program, and it resulted in $20 million in operating expense savings in terms of cost avoidance. And of course, it also helped in terms of safety. So this is another great example of a significant successful digital transformation. Another example here in the metals industry is ArcelorMittal Dofasco, which is part of ArcelorMittal, the world's largest integrated steel producer. Well, they realized that the real-time operational data was also important to their maintenance team. So after doing an RCM analysis, they identified a maintenance program for their furnace as the tap-hole refractory was eroding during normal use. They identified the specific conditions that were causing those tap-hole issues, and then the data was captured automatically with their real-time operational data infrastructure, and an alarm was generated when it was reaching certain conditions, which was automatically generating a work order request to resurface the tap-hole phase. And after the supervisor or the planner was looking at it and approving that automated work request, the company's CMMS, Computerized Maintenance Management System, was planning and scheduling the work order so that the work is done. So by doing this, they went from a time-based or calendar-based maintenance program to a condition-based maintenance program, and they saved $1 million per year per furnace, which represented total $19 million in total. So that's a significant improvement again. In terms of predictive, so going a step further, Barrick Gold actually, which can be considered as a pioneer also in terms of digital transformation, they had a long journey with their digital transformation, and they implemented predictive maintenance using IIoT sensors. Those are Wi-Fi sensors that are sending 4D vibration information to their real-time operational data infrastructure. And this new device, it's actually pretty small, easy to install. You just put glue on it and you put it on your asset. And for Barrick, it has already saved major failure at Barrick within only 2 months of implementation, which represented for them $600,000 of potential downtime for only one instance. And here we see those little white cylinders. Those are those new IIoT devices that are used to implement predictive maintenance on their assets. So it's quite an interesting story, easy to implement, and again, once you have access to all that data, you can do predictive maintenance. Now, back to you, Kyle, for our second polling question.
Yeah, thanks. It's time for the second poll. To anyone who missed it, just click one option, click submit, and then wait for the next slide to view the live results. All right, but our question here is, are you using advanced analytics or artificial intelligence for your operations? Our options are, we are using extensively and advanced analytics and AI to improve productivity and efficiency. We have just started using analytics and AI in some areas of operations. We are planning on using analytics and AI in the next 2 to 5 years. We have not planned on using analytics and AI. Okay, again, let's give everyone just a moment to think about that. Martin, is there anything you want to say about this question? What made you ask it?
Yeah, sure. So by the time people are answering that question, what we see actually is that some organizations have started or have tried using advanced analytics or even artificial intelligence. The challenge is that it takes time to prepare the data, and what we see is that 53% of the time of data scientists is actually spent on data preparation, and that's the issue that organizations are facing. They spend too much time preparing the data, and that's why we're saying that data needs to be contextualized first, so that helps in the data preparation time. You know, like I said, data does not mean information unless it is contextualized, and the result of it is that actually those organizations that are trying it and that are not necessarily ready for that is that less than 1% of that data is used for decision-making process. So there's a great challenge here, and the solution is really to start contextualizing the data so that we spend less time in data preparation and we use more data for decision-making process.
Okay, thank you. I think that's enough time so we can look at the results now. All right, there we have it. Again, is that kind of what you expected to see?
Yes, very interesting to see. Yeah, 36% have started using analytics. Now, next question would be how many are succeeding with it, and C, 39% is what I was really expecting. Companies are looking at it in the coming years, so it's very good. For those that have not planned on using analytics and AI, I hope that this webinar will help you realize the value of it, because there is strong value that can be taken out of it. But of course, before we start getting there, we need to start capturing all that operational data and contextualizing it. So that's the critical aspect here. Well, that's great. Thank you very much, Kyle. So moving on to our next section, talking about autonomous operation, and here we'll see an example of artificial intelligence. So another great area of improvement that is rising throughout the advanced analytics or the advanced digital transformation journey is actually autonomous operation. A lot of companies are looking into it. I cannot say that lots of companies have started getting in there, but there are companies that are there now. Cemex actually is a very good example. They started a digital transformation journey a couple of years ago with their PI system. They improved on many aspects such as asset health, energy management, environmental monitoring, reporting, etc. And now they have an objective to become autonomous so that they have autonomous manufacturing by 2022. So that's their strategic objective. So they started implementing AI solution on top of their PI system to analyze, predict, and prescribe the best operating scenarios. And the results were successful, actually. They are now able to operate their kiln autonomously, and they have strong operator acceptance. So this is a very good example of a company that performed a digital transformation in a proper way and then went to artificial intelligence. So now the results are great for them. I mean, they're reducing the downtimes, they're improving the quality, etc. So it's a very significant achievement. And here you see the different steps that they have achieved. You know, phase one, they started forecasting the predictions. So in real time, so they identified the output variables for the AI model to predict the behavior 5 to 15 minutes in advance. So once they realized that the predictions were good, then they went to a prescriptive approach where the AI model was recommending set points to the operator, and the operator were validating those set points, so correcting the model whenever there were discrepancies. And then once operators were comfortable with all of that, they started implementing the autopilot mode, which is when the AI model was submitting the set points for the control variables in real time to their control systems. So now operators are still there, of course, and they're monitoring in real time if the autopilot operation is aligned to normal operating parameters. And of course, they can disengage the autopilot mode in case of process disruption, power failure, etc., etc. So this is a very successful example of a digital transformation, like I said. And now they are at a stage where they're using artificial intelligence. Again, they did not start with artificial intelligence. That's a key aspect. So in conclusion, well, there are three keys to success, actually. First, your organization needs a clear change transformation story from management. So digital transformation, again, is a business transformation. Second, you need to implement an operational data infrastructure to manage your real-time operational data, to manage historical data, to manage future data, and most importantly, you need to have that infrastructure able to contextualize your data so that it becomes information, so that you don't spend all that time in data preparation and things like that. So your real-time operational data infrastructure needs to provide that functionality of contextualization. And then you need to empower your people so that they can take better decisions. You need to have them, they need to have access to that data, that contextualized data. They need to be able to implement, for example, condition-based maintenance, condition environment monitoring, condition-based process monitoring, etc. And those can all be implemented within the real-time operational data infrastructure so that it can be done in real time, which is critical to the success. And when we talk about having a real-time operational data infrastructure, well, we are, of course, talking about the ability to collect data from all assets at the bottom here, bring it into one single infrastructure, contextualize and enhance that data into your real-time operational data infrastructure. And this is where, in the middle, that you will put your condition-based monitoring for maintenance, for process, for environment, etc. once you have that contextualized data. And again, the same infrastructure is used to connect all those business processes on top to your assets on the bottom. So it all starts with the data. And at OSIsoft, we strongly believe that people with data can transform their world. Thank you very much, everyone, for attending. Now back to you, Kyle, for questions, the question period.
All right, thank you very much. It's time for Q&A. So a quick reminder for anyone who missed the beginning. If you want to ask a question, you can just type it into the box in the top left-hand side of your screen, click submit, and then wait to hear if it's read aloud. All right, but I see we've already had a few come in, so we can just get started. Our first question today is, what do you mean by history in quality assurance? Give an example.
What do I mean by history and quality assurance? Well, like I said, when you want to start improving quality, and I hope I'll be answering properly the question, but when we start talking about the quality, the thing is that most of the time we realize quality issues at the end of the production process. The problem is that once it's at the end, it's too late. There's a batch that has been produced most of the time, or there's a good number of products that were produced, or sheets, or depending on what you're producing, if you're a metal producer, or so the idea is to try to capture all those quality deviations during the whole process in real time, so that once you capture those deviations, you can, of course, reduce the number of bad products that are being produced at the end of your process. So that's what I meant. I hope I'm answering properly the question.
Okay, very good. We can move on to our next question, which asks, what patterns do you see in the mining industry with regard to which processes are the earliest adopters of real-time information initiatives?
What patterns? Okay, well, I think there are a couple of patterns for the mining, especially for the mining industry. Asset management is one of the key elements that companies are using real-time data, real-time operational data, because asset maintenance costs are significant for the mining industry. So this is one important aspect. Another very important aspect is also the recovery rate for, depending on the metals that the minerals that you're mining. But metal recovery is another significant aspect, and as we have seen with Goldcorp, I mean, they've improved their recovery rate, which is a significant loss. So those are, I think, two of the most important ones. But again, I mean, there are many others, but those are very important ones that we see a lot with mining companies that are starting to implement their real-time operational data infrastructure.
Okay, thank you. Another question asking, how do you develop a culture where the different functions can ask the right questions to ask of analytics and digital transformation?
How do we develop a culture? Well, I guess having people involved. I mean, if I take the example of Cemex, who succeeded, like I said, and even implemented artificial intelligence, the fact that they are involving people, they are involving their people, their operators into all those projects, that brings a cultural change within an organization. Again, first thing, and what the most important thing is that transformation needs to start from the top. I mean, management needs to be involved, needs to believe in that transformation. Once you have management, you have to have everybody getting into that. It's not, as I said earlier, it's not an IT-related approach. It's not a management approach. It is a corporate approach. So everybody needs to be involved in such a transformation, and that's what will allow you to succeed, and that's what will allow you to change your culture. When people don't have access to real-time operational data, they don't know what they can do with it. Once they start having access, once they start seeing what's happening, then they start realizing, oh, hey, maybe why is the amperage increasing here? What's happening? And then they start investigating because they have access. But if you don't provide them the access, there's no way that cultural change will happen. So you really need to have everybody involved, and everybody needs to have access. And that's what we say when we talk about empowering people.
Okay. On to our next question. What is the DNA of a client that is ready for such a transformation versus a client that wants to do it but is not ready?
That's a good question. Actually, a client that is ready, I would say, is a client that understands the value that they can get out of their digital transformation strategy. I mean, like I said, again, has to start from the top. So if management is not aware of what they can get out of it, they're probably not ready to get there. But once the problem or the challenge is to make sure that management see that there's value, and there is value. Again, I talked about the different areas of improvement. So depending if it's environment, depending if it's cost, asset reliability, I mean, there is value in using data. It's just that people need to see it. And once they see it, I would say they are ready to go into such a transformation. And everybody, I mean, I would say everybody, all organization, mining and metals organization, should get in there as soon as possible, because this is where we're heading to, and we see that there is significant value. And when we're talking about millions of dollars of savings for some companies in asset reliability or things like that, I mean, this is significant, and this is where you'll get the value. And with the commodity prices, with the challenges that the industry is facing in nowadays, we need to find those kind of solutions. We need to have new ways to operate, and a digital transformation strategy will allow you to get there.
All right, very good. So we've got a question here regarding real data access and view. Would you not contextualize it in terms of whom it is more valuable than it is? Should we not consider business process boundaries?
Let me try to understand. I'm not sure I'm getting the question here. What, can you repeat it, Kyle, please?
Sure thing. So it's regarding real data access. Would you not contextualize it in terms of whom it is more valuable, to whom it's more valuable? That is, should we not consider business process boundaries?
Yeah, well, okay, I think I get it. Business processes are definitely critical. I mean, having access to real time, and I would say, I mean, it's not one or the other. It goes all together. You know, when you start having access to real time operational data and it's contextualized, it needs to be integrated within your business processes. I was giving the example for metals companies that when processes are complex and require lots of different elements, I mean, it becomes very difficult to start monitoring it by the operators. But once you capture all that data and you present an understandable view of all that process, then it becomes understandable, and then you see or you highlight the fact that there are issues in this area of the process or in this business process, then people can act on it. But it definitely needs to be integrated. It doesn't go one or the other. So data it has to be used to improve business processes, definitely.
Okay, good. Question asking, what do you think is the future of Industry 4.0 in the next 10 years in the mining industry?
Oh, okay. Well, I think the future is now. Industry 4.0, again, it's a big term. It's a term that has been used extensively in the market. But I would say Industry 4.0 exists, has been there for many years, since we started capturing real-time operational data. I mean, this is Industry 4.0. We're capturing real-time operational data. We've been doing this for many years. It's just, I don't want to say it's a buzzword, but you know, taking advantage of that data is definitely what is the target of an Industry 4.0 initiative. And this is what we're talking about here when we're talking about capturing all that real-time operational data, contextualizing it, and doing analytics on top of it, or even implementing condition-based or predictive maintenance or process, etc. So those are Industry 4.0 initiatives, and it's been there for many years. Now, in terms of mining, of course, I've had a discussion with a mining executive once a couple of years ago, and the executive was telling me that, well, we don't need technology. We're just crushing rocks and extracting mineral. That's true. I mean, he's right. The thing is that nowadays, with the commodity prices that are happening, that are going up and down, I mean, we have to find new ways to succeed. You know, we have to find new ways to be more profitable, and this is one of the best approach that I would say So call it Industry 4.0, call it digital transformation, but this is definitely what will help mining organizations to go through to the current challenges that they are facing. So for the next, to answer the question, in the next 10 years, I would say most mining organizations will get in there if they have not already started, and that's what I expect. And I strongly encourage those organizations that they have not started to get in there to start looking into it, because definitely this will help them face today's challenges.
Okay, thank you. Another question asking, what exactly do you mean when you say that management team must establish a clear story for transformation?
Oh, okay. Well, actually, the McKinsey research team has identified 21 keys to success, and this is one that generated the most success in implementing digital transformation strategy within an organization. So initiatives that were supported by management, like I said earlier, were 3 times more successful than all the others. So when I talk about having management being involved, having management establish a clear story, well, it has to be a strategic project. It has to be a project that is followed by management, that is managed by senior management. I mean, executive support needs to be there. So I mean, you will need to implement that real-time operational data infrastructure to collect, contextualize the data, and deliver it. But you will also need to start involving people in that kind of project. Like I said, this is a technology solution, but of course it needs to be, you need to involve people so that technology will have an impact. Otherwise, implementing technology and not using it will not bring any value. So that's why management definitely needs to be involved so that people are available, people have time to work on it, people have time to implement it. And once people start using it, then they start realizing the whole value they can get out of it. So that's why when I say management needs to be involved and we need to have a clear story for transformation, it needs to be a strategic project that goes from the top. It definitely needs to be a strategic project coming, I would say, depending on the organization, coming from the general manager, coming from the president, depending on your organization. But it definitely needs to be a project that is being managed strategically from the top again.
Okay, thank you. Another question asking, in the first section you talked about empowering people with digital tools. What kind of tools will help in improving our efficiency?
Yeah, well, providing your operators, engineers, managers, and executives with the same information in real time coming from the same infrastructure brings already a significant value, because people are not struggling trying to assemble all the data that's coming from different systems. So the digital tools that will provide operators have to allow them to see the whole process, not only the local equipment they are operating. This will allow them to take actions. The example I was giving on the crusher, the operator on the crusher was a good one. And also Goldcorp, I mean, they provided their operators visibility on real-time targets, and this has brought results. So those are the tools that we're talking about. When we're talking about digital tools, it's basically to have access to the data, that is properly formatted. So that is contextualized and properly formatted or properly displayed. Again, this was also part of the McKinsey study. The challenge is to show that data, show things that are complex and bring it into an understandable screen or display so that people have the big picture and they get it. The best example I can give is you want to know if your plant, you're the general manager, you want to know if your plant is operating successfully. Well, maybe just a red light or a green light is enough. So that if it's red, then you can investigate a little further and see, okay, this is the area where it's red, and then you can investigate a little further and, okay, this is the asset where it's red, and this is where we're struggling, or this is where we're having an issue. So those are the tools that we're talking about here, the digital tools that we're talking about.
Okay, very good. Another quick question here asking, can you give an example of converting raw data into contextual data?
Yes, of course. Well, let's take, for example, you receive a raw data of 120. I mean, what does it mean exactly? Well, if I tell you that it is data coming from pump number 3, and that pump number 3 is located at the water treatment center, and that data, that 120, is in PSI, and it's actually happened at September 5th at 10 a.m., then you start to get context. Then you start to have meaningful information. And also, if I provide you the fact that the pump was operating normally at that time, and you know, those are all the things. This is all the context that we're talking about. So that 120 means something. But if I say 120 without all that context, you don't know what it is. So that's why we spend so much time, or companies that do not contextualize their data do spend so much time trying to figure out what is it, what was it exactly, that 120, that value. You know, data without context is only a value. It doesn't mean anything.
All right, thanks. Another question asking, what is the actual implication of data transformation to job roles and skills?
Interesting question, actually. And if we think about that example I gave for autonomous operation, I mean, for sure, skills, I would say, in that example that we had with CEMEX, you know, that they're implementing autonomous operation, operator skills are and will always be required. You know, it's not because we are using autonomous operation that we don't need operators anymore, because there are things that happen that the AI system will not understand, will not know what to do with. The operator will know. So the skills, let's take, I mean, the best example we can take is an airplane. I mean, we've been taking planes for many years now, and there is autopilot on the airplanes, but there is still a pilot, because whenever the autopilot has to be removed, then the pilot takes over. So it's exactly the same thing. So I think people will still need to be there. People will probably get more used to digital tools, and we can just think about mobile phones, or, I mean, who does not know how to operate a mobile phone these days? You know, everybody, our kids are just, I mean, they don't even speak, and they know how to use a mobile phone almost. So things are changing, but the roles, I mean, the roles will be similar. It's just that people, instead of spending time trying to figure out what happened, they will spend time trying to figure out, how can I make sure, how can I implement it into our system, into our infrastructure, so that it doesn't happen anymore, you know? So people will change the way they work in a way that again, instead of spending so much time analyzing, they will spend that time implementing approaches, implementing condition-based process monitoring, condition-based environment monitoring, condition-based maintenance, etc. This is where the shift will happen. So those people will still be required, but it's just that they will change the way they work. And that will have a significant value for our organization.
Okay, very good. I think we have time for one more quick question, which asks, when you talked about improving asset reliability, does this mean it's possible to implement real-time predictive maintenance with the PI system?
Actually, yes. You know, when you build, well, first let's start the PI system. Actually, when you start building your asset structure into your PI system, it will allow you to, of course, contextualize your real-time operational data and implement easily condition-based maintenance into your asset structure. So implementing condition-based maintenance is one aspect that is very easy to implement. Now, once you have this and you start using real-time analytics on that data that's coming from sensors, then you can start implementing, like I said, proactive maintenance if you're using, simple analysis. When you're starting to use advanced analytical tools that are building their own model or artificial intelligence, those are external tools, but they can all be integrated into the PI system, and that's what we were talking about when we were talking about future data. This is one of the important aspects. So it's all of this is done with the PI system. Again, the objective is to start by implementing that infrastructure, then implementing condition-based maintenance. There is significant value that you can get out of it. And then implementing, I would call it proactive maintenance with analysis within your PI system, within your real-time infrastructure. And then you can start talking about using advanced analytical tools, external advanced analytical tools. But start by walking before you run. That's an important fact.
All right, brilliant. That, unfortunately, is all the time we have today, which just leaves a big thanks to Martin for a great presentation, and of course to OSIsoft for sponsoring this session. To everyone watching, you're going to receive an email shortly letting you know how to access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. Thank you all once again, and hope everyone has a very nice day.